Cool, folks. We got a lot of people here. Thanks again for showing up, joining us. We've got, as always, Professor P, Peter West here, and we're today talking about SpeedFusion tunnels and configuring them and all the little nitty-gritty details you can find in there. So, Peter, this is one that I think people get lost pretty quick in when you start looking at all the different options and how to actually use these effectively. So I think this is one of those topics that we just can't talk about enough, really. And so I think a great suggestion for today. I'll hand it over to you to dive in.
Yeah, thank you. And I agree. There is uh can you hear that train or is that just me?
I can hear the train, but it's not
Okay, I
overwhelming.
apologize.
So,
Okay, I apologize. So this is a topic that gets brought up a lot, and I think there's a lot of confusion around speed fusion. And I kind of wanted to open up that conversation a little bit. And we've had lots of different discussions about configuring speed fusion. We just had the PCA. So if you were on the PCA, we talked about speed fusion, but I still get a lot of questions about speed fusion. Sometimes we'll call things, like the fusion hub, the speed fusion hub, or we think of it as a as the ability to bond on an individual router. And so I thought it'd be really nice to just have a video about speed fusion, and really just talk about how it works, what's needed to make it work, and the different solutions we have to provide it. And then more importantly, what makes us competitively advantageous with Speed Fusion for the salespeople in mind. SpeedFusion is a tunnel bonded VPN technology that allows you to aggregate multiple internet connections together to create a session persistent and reliable VPN connection between two endpoints. Boom, that's that's SpeedFusion. We don't have to watch anymore, right? We just gave it away. SpeedFusion is a VPN. At its core essence, that's what it is. It's a VPN between two Peplink endpoints. Now, what SpeedFusion does above any other VPN is it allows you to have our SpeedFusion technologies part of it. But in order to achieve SpeedFusion, we recommend, it's not a requirement, we recommend in Control 2, and we recommend, or there is a minimum of firmware of 6.1, which is when SpeedFusion was originally released, which is a long time ago. What's really cool about SpeedFusion, though, is it's a secure and seamless VPN solution. This means that we're talking AES 256-bit 4096 DH encrypted tunnels, but then those tunnels are broken up across all of your WAN circuits. So if you have 4 5G modems and 2 cable modems or 2 ISPs in your data center, that is 8 separate 256-bit encrypted tunnels. So it's incredibly secure, but then it's so easy. Sometimes it doesn't feel like it's secure, because I'll show you how easy using in Control 2 it is to deploy SpeedFusion. We also are not the endpoints can be behind a CG NAT or even a NAT or your personal network. And so what's really nice about SpeedFusion is only one side. We're going to call that the hub from now on, right? The hub site has to have public IP addresses or public facing IP addresses. They don't even have to have public IP addresses. They just need to have publicly accessible addresses. And all the peer sites, they don't need any public IP addresses or even publicly accessible IP addresses. They could be behind a NAT or a CG NAT, behind AT&T and Verizon and T-Mobile's private IP ranges. And that's what's so cool about this. You can create tunnels between your main facility, your hub, and your peers without the need of public IP addresses at the peers. This is a phone home technology. And that's also makes Peplink incredibly usable in today's world. If you especially think we talk about Starlink with the private IP addresses, and even ISPs not wanting to give out public IP addresses readily, cable modems and those guys, things like that. I mean, even the AT&T FiOS at our office that we use in our lab has just a NATed IP address, and then we can do the VNAT and things like that and hand off one public for that. But for the most part, ISPs are getting more and more reluctant to hand out public IPs, and so we want to be able to work with that. And with Peplink SpeedFusion VPN, you can do that.
Yeah, I think it's got this really neat quality to it that it's easier to set up than something like IPsec, but its capabilities are so much greater than IPsec. So it's easier and it's just way more powerful at the same time. And so yeah, it's um, that ease of use is actually makes it a lot more realistic and financially feasible to deploy too. Like you said, if you don't have to pay for static IPs on those carrier 5G networks, that's savings, and that makes it just easier to deploy and easier to shift. So looks like you're going to dive into some fun details here, though.
Yeah. So I figured the first thing to do, and I tell my, yes, that was legitimate train. um, so I figured the best thing to do is actually dive into a Visio and explain it, because just showing you in the router how SpeedFusion works, or on a doesn't explain why it works. So I'm going to open up a new tab here. We're going to create a new one here. I'm going to grab my SDX router, which is what I'm going to be using in my demos. So we're going to grab our SDX router. Now this is sitting in my data center. And if I go to here, this is my public IP address. So I'm going to go ahead and copy and paste that into our Visio. So this is our public IP address. So this is this is my hub, and this is my public IP. Now, let's say I had a firewall. Let's say you go, man, that would be super nice, but my corporation would never let me plug a Peplink router into my corporate network. No problem. You could also NAT this and do port forwarding. So you could assign this a DMZ IP address, 172.16.254.2, and a default gateway of .1, then do port forwarding or NAT mapping from the public to the private behind another firewall. And actually, if you look at this drawing right here, nope, that's a lie. If you look at this drawing right, I'm sorry, I have lab. There we go. This is exactly what I'm explaining here. So we bring in these ports inbound, and these are outbound firewall ports. So I'm going to copy this so you know in what we're talking about, what we're going to be doing. But you can actually plug this right behind an existing firewall if your corporation or your corporate policies require that you have a public firewall. And these are the firewall ports needed to make everything work. But I own my own network and I have a public IP address. So here's my SDX with my public IP. This is going to be my hub site. Once I've done this, the SDX supports 200 remote peers. So I could have 200 Peplink routers plugged into this router, into the SDX. So I have in my demo, we're going to have a transit. There we go. Transit duo. There it is. So we're going to have a transit duo. This is going to be my remote router. This is actually sitting in the Patriot with me right now. I'm not using it for internet so that I could give you this demo. And then I actually have a Starlink. So we're going to pull up a Starlink. I have the Starlink flat high performance mounted to the roof of my Patriot. I then have the Starlink power supply. And then I have two 4G. The Transit Duo is 4G. So I have two 4G internet connections. And so I've got T-Mobile and Verizon. And so these are my two internet connections. So I've got my T-Mobile, my Verizon, and my Starlink. And then I've got my Starlink power supply here. So, and if you're not familiar with this, the power supply has a little cable that goes to the roof and plugs into my antenna there. Then a power supply goes into the wall. This guy has a power supply that goes into the wall. And then there's an Ethernet cable that plugs in to my WAN. And then I have antennas that go to the roof for my Verizon and my T-Mobile. And that is literally in my RV right now is what I'm using for this demo. And then I have my SDX router over here, this hub router, and it has a public IP. Now my guys at the office went ahead and programmed that for me so I could bring it online so I could show you. Now, the reason why I did this is there's a couple ways to bond. One is a traditional VPN where I would do a layer 3 network. So in other words, if I wanted this transit router to access servers or services sitting inside of my office, like say I had an Active Directory controller or a NAS, so I have a NAS, and this NAS is 192.168.1.10. And my router here is 192.168. Oh, I'm doing an enter instead of a dot. I apologize. Dot 168.1.1. Dot 168.1.10. Let's just pretend I had a NAS. And if I wanted my remote sites to be able to access that NAT, they need to have layer 3 access. They need to be routable to each other. So this transit do up here has to have a different subnet than the network in my HD, in my SDX, my corporate office. So for the purpose of this is 192.168.50.1/24. And that's just the default IP address that comes with the transit, so that's fine. And these don't conflict. And the reason this is important is if you go to set up a SpeedFusion and it goes connecting, updating routes, then goes back to starting, that means there's an IP conflict on the untagged LAN. So in other words, my management network, my untagged network, depending on if you're a Cisco guy or not, this untagged default network that Peplink has, if they conflict, you're not going to be able to establish a VPN. And it'll go starting, authenticating, updating routes, starting. And that's because these two routers are conflicting in their network. There's two ways around this. One, change the remote network to make sure it doesn't conflict, 192.168.50. The other option that Peplink has is we can do something called NAT mode. NAT mode takes this router, makes the VPN connection a single IP address using DHCP of the SDX. This allows me, you guys are going to hear it training. Let me shut this. See if I can make it a little bit quieter. So this allows the as many transits as I wanted to have all the same IP address, 192.168.50.1, and not conflict with each other because they're being NATed. So West Networks, one of the things that we do is we have like a little SpeedFusion server that we let our customers sometimes tap into in demos, and we test SpeedFusion. We enable NATing on that so that it will actually bond, or it won't conflict with any networks, and they can test bonding without messing up the network. And so NATing is one way to do it, and the other way is layer 3. If you're trying to interact with your network, like I said, your NAS, or you want to be able to talk two-way back and forth, you want to make sure that your network is layer 3, which means they don't conflict. Once we have this set up, then we can create the SpeedFusion tunnel. So I can create a SpeedFusion tunnel between these two routers, and I can do this in control, or I can do this manually. So I'm going to show you how to do this manually first, and then we're going to delete it and then show you how to do it in control. Now, the other thing that we want to do is we want to demonstrate a couple different technologies. SpeedFusion has bonding. We will refer that as DWB. It has WAN smoothing, and we have FEC. So if I wanted to make a SpeedFusion tunnel that demonstrated all three of these, so I could use outbound policies to use different technologies based on my needs, I could actually create something called a subtunnel. And subtunnels allow you to create up to 5 subtunnels per SpeedFusion network. So once we do that, I can go back into my router. Here's my 2 routers right here. So I'm going to open up my SDX and my Patriot router. In the SDX, I'm going to go to Settings, Remote Web Admin. And in the Patriot, I'm going to go to Settings, Remote Web Admin. So in the main router, my SDX, I need to give it a local ID. So we're going to set our local ID to SDX HQ. Okay. And then here, I want to make my local ID Patriot. And FYI, that it's not political. This is simply, it is an American Coach Patriot SUV Sprinter, and that's why I called it the SpeedFusion Patriot or the Rebel or the Renegade. It's just the name of the RV. So just throwing that out there. Okay, so we're going to go to Advanced. And right here is my local ID. So I'm going to go SDXHQ. Hit save. And now I can create a new profile. So I can hit new profile and I can say transit duos. I can even enable or disable encryption. So if I'm using this for just maximum bonding throughput and I'm not passing PCI or secure information, I can turn this off. If you think about this going out to the internet, you plug your cable modem into your router. You don't have an encrypted tunnel there. That's just internet. If you're just using this for internet, you can save yourself 5% of overhead and turn off encryption. So here I can do my remote ID. My remote ID is going to be Patriot, and I can add multiple remote IDs here if I wanted to. So if I had the Rebel and if I had the Renegade, I could have all three of my sprinters right here on one profile, and I could just call this sprinters if I wanted to, and literally list the remote ID, have a separate pre-shared key right here. So I could put in a pre-shared key that they both have to have. I can also allow shared remote IDs. If I do allow shared remote IDs, this would allow multiple devices with the same ID of Patriot to connect in. So I could say if I just wanted to have a bunch of sites quickly set up with the exact same profile settings, I could literally say SpeedFusion and hit shared ID, put a pre-shared key in there, and be done with it. If I wanted to NAT these devices, I could click NAT and it asks you where you want to give IP. If I check this NAT, when the transit connects in, it's going to say NATed, and it's going to give me an IP address on the SDX 192.168.1.10 or whatever the next DHCP available is. Turn that off. I can assign a cost to this. This is going to be for OSPF. I can assign a data port. So if 4500 and 32015 aren't available or aren't usable, I could actually go to custom and make this 443 if I wanted to. Be careful when you're doing that, but I could. I can also click this question mark, click here to configure stream protocol, and I can change this from UDP to TCP. I've had instances where carriers will throttle or having issues with UDP. We switch it to TCP and it improves the throughput dramatically. There is a cost to that because it retransmits a lot. If you're having packet loss or retransmits on your network, sometimes TCP won't be as fast as UDP. But in the event that UDP is being throttled, TCP is a great way to do this. But now if you think about this, if I'm creating a tunnel on TCP 443, most like hotel firewalls, airport firewalls, etc., aren't going to block it. The other thing you could do is UDP 53, right? Almost nobody blocks DNS. So you can actually customize these ports as you see fit. Just be aware that it might act weird, and you want to make sure your hub router isn't acting as a DNS or web server on 443. So I'm going to hit allow. I'm going to go back to UDP auto and UDP because that's fine for me. Here you can set up a bandwidth limit. So I can actually throttle this specific tunnel. So I can make this tunnel limited to 10 megs up by 10 meg down. This is really good if you have, like, say you're connecting to T-Mobile 5G, getting 500 or 600 megabits of internet, and you don't want to suck through all of your bandwidth. And so you want to limit yourself to 30 or 40 megabits per second. So that way they get enough bandwidth to do their jobs, but they're not sucking up all of your bandwidth, your gigabytes that you would have for the month. So you can actually throttle the tunnel as you see fit. TCP ramp up. This is a really cool technology that if you see when I turn this on, it turns off WAN smoothing. TCP ramp up enables WAN smoothing for TCP sessions for the first 5 seconds. What it does is basically says, hey, I'm going to accelerate the utilization, the packet delivery of TCP sessions, and by enabling WAN smoothing. And then it's going to turn off WAN smoothing and allow that to go faster through. It's basically a way of ramping up TCP sessions so that they can take the most advantage of a circuit possible. WAN smoothing is our parity bit. So it's which we'll probably have a slide on this, but WAN smoothing enables parity bits by almost like a RAID array. If you're familiar with that, it's going to duplicate packets over multiple WAN circuits, which will eliminate spikes and jitter and latency. So the idea is reducing latency and reducing jitter by dropping high latency and high jitter circuits. And And so if you have packet loss or jitter or latency on your path on one of your ISPs, they'll simply be ignored because double the date packets are being sent. If you do WAN smoothing, it is sending double or triple or quadruple the packets. So that means you're going to use 2, 3, or 4 times as much data as you would normally with standard bonding. So just be aware of that. And that's why TCP ramp up, the idea here is to get some utilization of the circuit fast without costing you WAN smoothing the entire time. Forward error correction, it uses parity bits. It's built for like broadcasting, where it's like a one-way stream, and it only uses 13 and 26% overhead instead of 100, 200, and 400%. So you kind of have this low and high. So the low is going to be 13% and high is going to be 26%. And so it lets you add parity resiliency without sucking up an entire stream's worth of overhead or bandwidth. Packet fragmentation. When I think this got messed up in 8.2 firmware-ish, but when we started messing around with SpeedFusion and people were trying to deploy during COVID, people were trying to deploy Cisco access points over SpeedFusion networks. Their Cisco APs wouldn't talk, and it's because they had this DF flag, and we needed to block the DF flag because basically we're fragmenting over SpeedFusion, and it was messing up the Cisco APs. So this feature allows you to fragment Cisco APs when they say do not fragment on the DF flag. And then dynamic weighted bonding replaced traditional bonding. It's now the default with, I think it became the default with 831, if I'm not mistaken. Dynamic DWDB became the default bonding. And you have your congestion latency level. The idea behind dynamic weighted bonding is to mitigate congestion by detecting packet loss and latency. So basically, if a tower is congested, if there's too many people using that tower, the more data you consume, the more latency you're going to have. It's going to spike up. It's going to be like 80 milliseconds idle, and then it's going to go to like 1,600 or 3,000 milliseconds of latency. And the reason is because there's not enough bandwidth on the tower to give you the internet, the usage you're requesting. So what we've decided is, what we've done is dynamic weighted bonding monitors latency and then will throttle the circuit down until it's within an acceptable latency window. So making sure you don't use too much bandwidth. What this really does is traditional bonding would not allow you to bond circuits that are more than 50% off of each other. So if you had, well, it would allow it, it would just affect the performance. So if you're bonding like a 100 meg circuit and a 50 meg circuit, in theory, you'd only get the 50 plus about a 75, but actually you'd lose about 25 megabits of throughput. Then you would then have the 18% overhead with bonding, and it would take away additional throughput. Dynamic weighted bonding will allow you to have disparate links and better handles those. It still isn't perfect if you're getting like 25 kilobits per second, like if you're being throttled by the carrier to that 56 kilobits or something like that. It doesn't work well there. But outside of carrier throttling, it's great for congestion detection and management.
Yeah,
Ignore
in
packet
a
loss.
nutshell,
Oh,
it's the 5G version of bonding, right? It's so
yeah,
different than wireline networks, and so that's really what, there's not any company out there that's able to keep up with the pace of how these networks are taking shape and optimizing performance on those networks better than Peplink. And that's really what dynamic weighted bonding is. Every
yep,
single firmware version, there is an update and an improvement to that algorithm because these networks are getting built out still to this day. And
yeah.
so
They're
the things,
constantly evolving, and you want to be with a company that can evolve with those technologies, and that's what Peplink does. Ignore
yeah,
packet loss events basically says, hey, don't treat packet loss as congestion. So it's saying that packet loss does not mean congestion. It means that it's just a crappy circuit. I'm sorry, I should have said that on recording. But it's basically saying don't treat packet loss as congestion. And then you can disable buffer bloat handling and disable TCP ACK optimization. And then you can set a packet jitter buffer. Default is 150 milliseconds, but if you need that to be more strict, you can lower that. It's just be aware that that's going to be our jitter buffer that's kind of there to help you create the best bonding environment. Now, then at the bottom, we have our WAN connection priority. WAN connection priority is the order in which these WANs are going to be used. So I mentioned this is now this particular router, this is my hub router. So I only have one internet, WAN 1. But when I get to my transit router, I'll show you something different. If you click the question mark here, I then can enable asymmetric connection testing. I can enable connection mapping. I can enable cutoff latency. And I can enable suspension time after packet loss. All of these are designed to help you manage different WAN environments. So for example, say I have 4 AT&T and 4 T-Mobile, and AT&T only has band 14 and 66, and T-Mobile only has band 25 and 41. I could make one AT&T upload on band 41 or band 14, download on band 14, upload on band 66, and download on band 66. And so one entire SIM is being used for downloading on band 66. One entire SIM is being used for upload on band 66. And so you can actually customize how how your internet circuits are being used for upload and download over SpeedFusion. You can also tell it which connections it's allowed to. If you have a Cox fiber line at one location and a Cox fiber line at the other location, and they're getting 3 milliseconds of latency between them because they're on the same hub, and you could do large files, I could say WAN 1 on this router only talks to WAN 1 on the other router. So Cox only talks to Cox, and they can use their internal network. It's not leaving that network to be able to talk to each other. This is also used for private networks. If I have an MPLS circuit or a private wireless network, I can say those two devices, it's a private network not going out to the internet, just talk WAN 1 to WAN 1 or Wi-Fi to Wi-Fi. And it's going to do that for you. That's actually how we do MPLS and private networking as well. But we've also used this with common carriers connecting. So if I have Unity and at one site and Unity at the other site, and I have Cogent at one site and Cogent at another site, I could say Cogent talks to Cogent, Unity talks to Unity, then bond those together. So I'm still bonding Cogent and Unity, but they're staying inside their network. They're not talking cross network and then leaving their infrastructure. So it's a great way to optimize performance based on your needs. Cutoff latency, this says, hey, this is the maximum latency that I want to have. If you want your maximum latency to be 150 milliseconds, you just put that in there. Now, if you're doing that over cellular or Starlink, I would hesitate to put 150, maybe 300, but you want to, you can say, don't use this circuit if the latency exceeds a certain latency. And then suspension time after packet loss. This says, hey, suspend this circuit after packet loss is detected for a certain amount of milliseconds. So you could say, hey, suspend this for 3 seconds or something like that, because I don't want packet loss on my network. So latency, this is latency to the destination, the way Peplink works. Someone asked the question, is the cutoff laser measured per provider network, or is it measured all the way to the SpeedFusion cloud exit point? So it's measured to the hub device. So this is between hub and spoke. So this is the latency between the hub and the spoke. So it's measuring the actual connection between these devices, and then it's and that's the latency. So if that through your entire network, through all the internet between the hub and the spoke, that's the what's being measured there. So one last thing with manual provisioning is if I go to the very top SpeedFusion VPN profile, click the question mark, I can right here to configure multiple tunnels. Click here. I can create multiple tunnels. I can create up to 5 different tunnels. And these tunnels can now have their own settings different from each other. So I can make a setting called WAN 1. And literally, I could say WAN 1, let me just say off, duplicate that down, WAN 1 on, and literally this tunnel will only use WAN 1. I can make another tunnel called WAN smoothing and turn on WAN smoothing. I can make another tunnel called FEC and turn on FEC. I can make another tunnel that is mobile internet only and I could say mobile. And so I can create these tunnels. Now, when you're manually creating these tunnels, these names, this tunnel name must match exactly on both ends. So you want to make sure that what you're doing on the left, you're doing on the right. So if I'm doing this on my SDX router, I need to make sure my transit router has the exact same names and spellings for these tunnels. I could also create another tunnel called VLAN 10 layer 2 and make a layer 2 span of VLAN 10 and use a subtunnel to span the VLAN 10 over layer 2. So that's a very common way. It's something that we do here is we'll do if we want to span VLAN 10 and layer 3 route all the other VLANs, I can create VLAN 10 on both routers, the SDX and my remote, and then use this tunnel to span layer 2. I'm not going to do that right now. And so if I did this, then I could hit save and apply changes. And I'm going to get the Sprinter's network here. Then I go to my Patriot router right here. Hold on 1 second. I have SpeedFusion IC2 enabled. Give me 1 second. Delete, save changes, turn off, save changes. And then I can go to my SpeedFusion Patriot and I can give it my local ID, Patriot, hit save, create a new profile. We can call this SDXHQ, remote ID, SDXHQ. Nope, oops, sorry. SDXHQ. We're going to turn off encryption. So here's where everything, like I mentioned, everything has to match. So I'm going to click this question mark, click multiple tunnels. And so this one, we have the WAN 1. So I need to call this one WAN 1. Now, I don't have to only have WAN 1 on this one. I can name it something. I can use it for something else, but I need to have it there. WAN smoothing, FEC, and mobile. You can see how kind of annoying this is. I'm actually doing this on purpose because I want to show you guys how much easier life will be. So this one, I'm going to turn on WAN smoothing. This one, I'm going to turn on FEC. This one, it's going to be mobile only. So I'm going to turn off all these and just do cellular 1 and cellular 2. And this one, I could actually do my Starlink, which is WAN 1. So I'll go ahead and do it just because it's, why not, right? Off, duplicate, WAN 1. Okay, so we got WAN 1, WAN smoothing, FEC, and T-Mobile. And then I got to put in my public IP address of the hub. Which is right here. Put it in right there. Hit save. Oop. 1 second. I think when I disabled the profile there. Okay. Save. There we go. So if you notice there, I lost connection to the router because what I did is I deleted the profile, which had outbound policies. And so switched over. And so the tunnel needed to be created. All I did was go back to the in control, create a new remote admin session, refreshed my session, and then clicked save changes and it worked just fine. Click apply changes, go to dashboard, And I should be able to go to the dashboard of this guy. And there's all of our tunnels starting. Oh, there you go. So updating routes. Normally when I'm creating my training videos, I pause during this section. So it's like a cooking video, kind of the cake pre-made. So I pause the video, wait for all this to establish, and hit start. So you guys get to watch it in real time. I'll answer some questions while we're waiting for this to establish. Okay. We experienced weird issues with these priorities. We have Starlink and several 5Gs when using, and when our users go over the Starlink subscription, so the Starlink still shows as on, but none of the data goes through. Unfortunately, that's not a clear enough question for me to be able to answer, Stig. But if you email either Travis at peplink.com or Peter at westnetworks.com, one of us would be more than happy to get you in contact with a partner and or help you step through that. I would need a little bit more detail to answer that fully. Issue with data loss on FW IPsec tunnels transiting Peplink SpeedFusion tunnel. Any links? So if you're doing IPsec over SpeedFusion, you want to make sure you turn off NAT-T. So if you go to advanced and service pass-through. So service pass-through is an option right here, IPsec NAT-T. Default is enabled, and it's going to make it difficult to force IPsec traffic over SpeedFusion. It's going to try to use a WAN circuit. So if you want IPsec clients on your network to traverse SpeedFusion, you want to turn that off and hit save and apply. And that's going to allow IPsec. If there's another issue, you'd have to get the logs and troubleshoot it. But that would be and whenever I hear IPsec issues over SpeedFusion, the first thing is turn off IPsec NAT-T. In a troubleshooting scenario, is there a log section where I can WAN names are correct? It's hard to, I don't know if there's WAN names are correct. That's just syntax, unfortunately. Why is this still spinning at obtaining?
I wonder if the page didn't get.
Oh yeah, I don't think the page loaded there because we do have it activated there. Refresh. Nope, that's weird. Smoothing. This is why I hate manual creations. By the way, I'm going to show you straight up that this is why manual tunnels is annoying, because everything has to be right.
There is a little bug in 841 that if there's not a LAN side device, the tunnel
I don't have a LAN plugged in, so
might be that.
It's not going to update routes. That's right. I remember that bug. Okay.
I hit
Well,
that
anyways,
wall
it did. Yeah, that's why it's spinning up updating, because I have nothing plugged into the LAN of this transit. So, but anyways, that's how you do it. And it did connect. So we're good. I have nothing plugged into it. So you can see that right there.
It's basically a lab impact bug, right? If there's not any clients on your device, your lab device may not come up. And so we found this bug. It's a known issue. There's a fix for the firmware, but in these kinds of scenarios.
8842.
Yeah.
Okay. Well, that's how you create tunnels in the router. And it did come up, just not all the way, because it's that's why the other side stuck. I remember that now, because the client said it's spinning and updating routes because there's nothing plugged into this router. So then we can talk about manual doing the same thing but inside in control. So I'll show you how much easier this is. Set SpeedFusion configuration, enable, add a tunnel, star, choose my SDX. Look at that, public IP automatically shows up. Choose my rebel, click next, click show advanced settings. And now I can hit SpeedFusion, or I could name this Sprinters. Turn off encryption. Dynamic weighted bonding is automatically enabled. Here I can have my WAN smoothing is disabled, TCP rep is ramp up is disabled, forward error correction is disabled. And then I have this link settings right here. I click link settings. And you see right here, tunnels 1. I can click edit, add, and I can go down to tunnel 1 and name this WAN smoothing. WAN smoothing. And then I can go in here to smoothing, normal, smoothing, normal. And then I could add another tunnel. I'm only going to add 2 for the essence of safety and time for everybody. FEC, FEC, and then I can turn on FEC low and FEC low. So basically what I have is my default policy, which could have like TCP ramp up enabled, but just that and dynamic weighted bonding. Then I have a WAN smoothing one, and then I have an FEC one. So then if I hit save, it's going to warn you that only the primary tunnel is going to work without outbound policies. And so it's going to say, hey, you got these tunnels. You have 3 tunnels here. So I can hit save. Then I can go to my WAN settings. And now I can configure those same WAN settings. You see, I've got 3 tunnels, FEC, WAN smoothing, and primary. So I can click on the Patriot to WAN smoothing, click modify WAN settings, show advanced, and all those same options show up under WAN settings. So everything I just did on the manual mode, I can do inside in control, except for it's going to guarantee all the syntax. It's going to make sure everything's typed right, everything's properly brokered, the keys are properly set up, and you can set up those same settings. Hit cancel, hit close, hit next, hit finish, save changes, and now the tunnels will rebuild using in control. Oops. There you go. So you see that connection to Patriot, primary, WAN smoothing, and FEC. So we have our 3 tunnels. Ooh, a whole bunch of questions here. Let's see here. When I add a new WAN connection to my bonded tunnel, like a 6th WAN to a 5th WAN, the tunnel disconnects and reconnects. Well, if you're changing the WANs, it's going to re-provision, and therefore it would disconnect and reconnect, right?
That would be my expectation too, yeah.
Yeah, I mean, I would say when you're configuring the tunnels, when you reconfigure, it's going to do that. If you have all 6 of them connected, as long as it stays connected, you should be fine. Like I should be able to have 6 WANs, unplug one, and as long as that connection isn't the public IP that's being used, then it should still work. Otherwise, there's another question, just email tech support. And troubleshooting scenario, is there a log section where you can check the WAN names? Oh, I already did that one. I guess the last time I tried turn on SpeedFusion for bonding, it has a monthly quota. There's no monthly quota for bonding. There's a monthly quota for SFC, which we will go to in just a second. Do you have an SDX on the other end? Could you use a BR1 Max? Yes, you can use any Peplink router. I have an SDX because I have a plethora of routers, but but you could use any router that supports SpeedFusion. The BR1 Max, you got to be a little careful of because depending on which hardware and firmware you have, they don't come with SpeedFusion, but the BR1 Pro would. But any of our low end, like the BR1 or the 20X or the old 20s, some of those had to have prime care for SpeedFusion. And if you have 841 firmware and you have it connected to in control, it downloads the free SpeedFusion bonding license, and that's now persistent. But if you have an older firmware that doesn't support 841, that would not be the case for you. So BR1 would be the one bad example there, that it might not work with every BR1, but it would work with most BR1s or modern.
Yeah,
BR1s.
the other big consideration is just knowing that your head end device will be potentially a bottleneck for the remote devices. So you need to
Correct.
make sure you size that head-end device appropriately for SpeedFusion throughput and your WAN links.
Yeah.
But
Yeah. So
technically,
SpeedFusion
yeah,
is
and go
Yeah,
ahead.
SpeedFusion is available on almost all modern routers. So all 2023, 2024 routers, SpeedFusion is available. Um, you just need to make sure that the SpeedFusion bonding performance is there. So, for example, if I have the Transit Duo and bonding to an SDX, I've got more than enough bandwidth to support that. But if I have an MBX HD4 5G and I have a Transit Duo as my hub, that's not going to work, right? I mean, I'm going to get way more bandwidth on a bonded 5G than I am on the even though the Ethernet plugged into the Transit's gigabit, the Transit doesn't support 500 megs of bonding internet, and therefore you're going to throttle or create a choke point on your router. So we got the exact same scenario. Once again, I have nothing plugged into my LAN, so I apologize. So it's just gonna be stuck at updating routers, but you can see that the primary tunnel established and the other stuck on updating routes because I have nothing plugged into it. And so you can see how easy it is. Now, we're running short on time, so I do want to cover SpeedFusion Connect. So we talked about creating bonding and subtunnels, so we've done that here. The next thing is Peplink has a public bonding service. Say, this is awesome, but what if I don't have an SDX or another router or a home connection? Peplink has a cloud service called SFC Protect. SFC Protect is Peplink's geo-redundant, diverse, I guess, bonding service, cloud bonding service. This allows you to create a bonded tunnel between your mobile router and the internet without the need of an infrastructure like an SDX. The downside to this is that one, it's limited to 200 megabits per second. So it's limited to 200 megabits per second. You have a quota. So after you use your quota, you're going to be limited to fair use. So after the quota, you'll have a fair use of 10 megabits per second. And then it's outbound. There's no public IP or inbound connectivity. It's an outbound bonded service. What's nice about this is if you have an RV, for example, or you're working from home, SFC was built for the RV or the work from anywhere person. If I'm working from my RV like I am right now, actually, and I wanted to protect this internet, let me go to my Transit Duo here. So here's my Transit. I could go to the network tab, that's SFC Connect, go to client mode, I'm just gonna choose automatic, hit the little green checkbox there. I can click on this SFC. I can create all those same tunnels. I can create a WAN smoothing and I can create an FEC and a regular bonding. I can create all the same settings. Hit save, hit apply changes. But what's cool about this, under the SF Connect tab, I can then route by application. So I can say Google Meet, Zoom, Microsoft Teams, and you can, I'll let you see the whole list here for a few seconds. And all of these applications, I can route dynamically over SFC. So if I'm in an RV and all I have is a BR2 Pro 5G or a Transit Duo with Starlink, I can protect my Teams and my Google and my Zoom meetings. I can make all of those function reliably while my Netflix and all those other applications can just use the regular internet. So my Starlink or my 4G or 5G connections. And so this protects my Zoom calls, but allows me to use the internet. SFC is a publicly hosted VPN, which means Hulu and Zoom, or I'm sorry, Zoom, Hulu and Netflix and YouTube video, TV will see this as a VPN, and they're going to say, "Hey, you're on a VPN," and they're not going to let you to use it a lot of the times. So SFC was built by Peplink to provide users with quality bonding for their mission critical applications. If you want to be able to watch Zoom and Hulu and all that stuff, or not Zoom, I'm so sorry, Netflix and Hulu, Peplink set up a special SpeedFusion Connect service called Relay. relay mode. Relay mode is powered by SF Connect, and you can plug this into your home router. So at your house, let's take the same setup. Control C. I'm going to make a new tab real fast. Control V. You can install I don't think I have a B1 icon yet. Nope, we'll do a B20X. Okay, we'll do a 310 5G. You can plug a Peplink router at your house. You can plug this Peplink router at your house into your cable internet, broadband. And this does not have to have a static public IP. This can just be plugged right into your cable internet, no static public IP. It has Wi-Fi, it just replaces your router. This can be any IP address it needs to be. Then you can use relay mode to connect your transit over SF Connect to your home internet. And then you can route all your traffic to your home. This way, your DVR, your Netflix, your Hulu, your YouTube video, it looks like you're coming from your house. So as you travel the world, boom, done. And the way to do this is on your hub device. So I'm going to go back to my SDX. I can go to SF Connect, choose relay mode for inbound access. So we're going to pretend I don't have a public IP. I have to choose a location. So we're going to say I'm closest to it. Well, I'm closest to Atlanta, but I don't have that one. So I'll do Dallas. Hit OK. And I'm going to get this code right here. You see this code? So I just go Control C, apply changes. And then on my transit, I can go to client mode, relay sharing, put in that code, hit the green checkbox, apply changes. And now this transit duo is going to talk to that SDX via SpeedFusion Connect. And so now I don't have to have public IPs. I don't have to have any inbound port forwarding or anything like that. They're going to connect together. Now I still be limited to my 200 megabits per second. It's still going to use my SF quota, but now I can send all my traffic out the tunnel. So now what I can do is go back to my SF Connect, go to route by SSID, and right here, relay, I can choose my Wi-Fi and I can make this Keter West relay. Hit add. It's going to create a new SSID called Keter West relay. Anything that connects to that SSID automatically looks like it's coming from that SDX. It's going to send all the traffic over SpeedFusion Connect to that relay. So you can have your smartphones and your TVs and your tablets and things like that that need to use Netflix or Hulu on the relay Wi-Fi and let them go out your home internet, and it'll look like it's coming from your broadband circuit at home. Okay, will it be a SpeedFusion app for Peplink's future to allow clients to assign? Yes, so they already have a SpeedFusion app. Oh, clients, no. So we have a SpeedFusion app, but it's not for client VPN. We use OpenVPN for that right now. I really, really badly want a SpeedFusion app. So I'm going to say, hey, Peplink's on the phone here. Can we have a SpeedFusion app? But unfortunately, it does not exist yet. We use SFC Protect using several data centers worldwide, maritime industry. Yep, yeah, it works. It works great for maritime applications. Sometimes websites are not working due to the public IP of the data center. So it can't be solved. So this is not an issue or a bug. This is what I'm talking about with VPNs. Netflix and Hulu and other providers will block VPNs. We're using a public data center like Cloudflare and a few others to have Fusion hubs for you to use, and it gets seen as a VPN. The only solution is what I just said, relaying it to a data center or your house. So you can either bond back to your office, like if you're an MSP, bond, host a Fusion hub for your clients. If you're or put a Peplink router at your house and use your cable internet to bond back or get fiber internet at your house. If you have a yacht, I'm sure you can afford that. But the SFC, the SpeedFusion Connect, is only going to be good for bonding your Zoom and Teams and things like that, because there are websites that are going to see that as a VPN, and there isn't a way to solve that in the future. It's a publicly available service, and therefore the answer is bond it to your house and bond it to a corporation using standard SpeedFusion. Change both LAN, IP, and subnet on each device, or can just change. I don't fully understand the context. Maybe that was part of another conversation.
Yeah, I'm typing through there. I think.
Okay.
When I was
Optimized cloud application is not possible. Is it possible to exclude services? Not really. Once again, Yahoo knew that you want to include, not exclude, for bonding. So not really. There's no real easy way to exclude services in an outbound policy. Multiple WAN connections above. On one side is the new B1. Yep, and the other side is a balance 2, both on latest firmware. Oh, I guess that's someone talking to you. Is there any plans to increase connection bandwidth on SpeedFusion Protect? I've heard rumors, Abby, that there are plans to increase or have like an enterprise or higher performance bonding. But once again, that really goes back to just throw a Fusion Hub in AWS Azure Global Cloud. I mean, the Fusion Hub, I talked about this SDX, that's expensive. You can download the Fusion Hub for free. Like for free. So if I went to go back to Peplink University and I go to organization, warranty, and licenses, I can scroll down here and say, acquire Fusion Hub, solo license, acquire, send this to my Patriot, SpeedFusion Patriot, proceed, continue. Boom, there's a license and serial number. Now, inside my group, there's a Fusion Hub. I can take that Fusion Hub, throw it in AWS, Azure, Google Cloud, or my house, or anywhere I want, and bond my SpeedFusion Patriot and have unlimited bandwidth. Well, the limitation of the Transit Duo or MBX or any other router. So Peplink has a lot of solutions for bonding. That's what's so cool, is the SFC is just requires no infrastructure. But once you outgrow the SFC, we have a lot of options for you, like the Fusion Hub Solo, or relay through your house, or setting up a dedicated router at your house with a public IP, or setting up a Peplink router at your office and bonding to that. And so there's a lot of options to increase throughput. The idea is to know what options are there and why we would need those options. Private cloud applications with my Peplink router via SFC. So if you want to connect your public cloud applications with your Peplink router via SFC, then you would want to use the relay mode. But I would need to see your private cloud. You'd probably have to have, that's, Matt, if you email peter@westnetworks.com, or if you have a partner, email them, or email me and I'll help you get in contact with your partner. That would be a fun one to architect, but probably outside the scope of this call.
Yeah, and that's outside of the scope of SpeedFusion Connect. That's really what Fusion Hub and the routers are there for, is those advanced scenarios. And SpeedFusion Connect is just for those internet public applications, like you said, Peter. So I totally agree. That's a good partner conversation.
Yeah, it's a good partner. So someone asked if you could show the unbreakable meaning of SpeedFusion. So let me show you why we call that this, or why we call it that. Give me 1 second. So let me go to here. So on my Patriot, if I go to my Patriot router here, if I go to status, because we bond, if I go to my status SpeedFusion VPN, you're going to see all my tunnels here. And so if you see here, my SpeedFusion VPN, I have my connection to SpeedFusion Atlanta, my connection to Detroit for my home. And you can see here, this is my Starlink WAN and my 2 cellulars. So because I'm bonding these, any one of these connections can fail, and my connection, my stream, will not fail, as long as I'm using outbound policies to control the flow of that traffic. then that connection is going to be persistent. So once you get your tunnels up and running, and I do apologize, everybody, we're going a little over. I hope you guys. I see a bunch of people staying on. I'm so thankful for this because there's a lot of information to collect here. Um, Once you have your tunnels established, I showed you how to do outbound policies using SF Connect, but you also need to create outbound policies to use your tunnel once you create it. So once I set up a tunnel, I can go to advanced, outbound policy. And what I like to do is bond all my traffic to my data center when I'm creating my own network. So if I'm on my mobile units, I'm bonding all my traffic. So, but then you could create a policy called bonding. And here now I can be more specific. So I can say if the source is my camera's IP address, camera IP, right? Or if my source is some device, or if my destination is a streaming service, youtube.com, right? So if my destination is YouTube, and then I can say enforce priority, weighted balance. I can create a policy. I'm gonna do priority just because it's one I like. And then I can say send that traffic using WAN smoothing or FEC. It's probably a more appropriate one because I'm streaming. Drag all these off. So I can create a policy that says, if I'm streaming to YouTube and YouTube gives me a link like rtmp.youtube.com or whatever, and I say if my domain name is youtube.com, send this over FEC. And then I can say if there's nothing available, fail through the next rule. But if my router is booting up and the tunnel's not created yet, terminate the sessions and move them over to FEC. So if this tunnel goes down, fail through. If it comes back, move the traffic back over to the FEC. This policy says, hey, no matter where I am on my network, on my transit, if I'm going out to youtube.com, I want to make sure that I'm using FEC. So my stream's going to be reliable. If I'm going to what's that, Vimeo or whatever, stream server, whatever, stream domain.com. So whatever my streaming domain is, send it out there. It's going to then send that traffic over FEC. I could also say any protocol UDP and pick real-time streaming protocols, right? Like RTSP, or I could do SRT. Oh, I don't have RTS, but I'll do RTSP. But anyways, you could do a real-time streaming protocol and basically say, if my real-time streaming protocol is detected, send it out FEC, protecting that traffic. One of the things that I like to do personally is and once again, I'm a little spoiled. So I'm going to admit that straight up. I'm a little spoiled, but I have my SDX. It's plugged into a 9 gigabit internet connection. It's got static public IPs. I just bond all my traffic. So if you look at my personal router that I'm using right now today, so here's my T-Mobile, my two T-Mobile 5Gs. Here's my connection to my head-end unit, and I'm simply just bonding all traffic back. And so you can see there's my, 70, 72 milliseconds of latency, 0 packet loss. And this is my stream that I'm using to talk to you guys. So I just bond all my traffic back to the head end and actually just protect everything. That keeps me up and running and reliable and makes sure that I'm good to go. And that's what we mean by unbreakable. When we talk about unbreakable, it's combining 2 or more internet connections to create a super reliable connection.
Yeah, I've seen a lot of questions too about how that plays out. Like there's a few different terms that we talk about, but in the GUI, it's not clear what or where those things are. So like hot failover versus bonding. There's no hot failover button in the tunnel setup. And so it's kind of tricky because it's basically implied when you've got priority 1, priority 2. Hot failover is switching from priority 1 to a priority 2 connection.
Yeah. So if I go to my
go ahead.
Yeah, I was gonna say, so if I go, like, for example, for hot failover, if I go to my connection settings here, show advanced, and go to my WAN links, hot failover says Patriot, primary tunnel, modify WAN. So use my WAN, then use my cellular. So what I'm doing is saying use the WAN first, then the cellular second. That's hot failover. It's going to use that WAN circuit, and then if the WAN circuit fails, the cellular is going to kick in. That's hot failover. And so, now in order for that to work, all of the connections have to be active on the router's dashboard. So in the router's dashboard, you want to make sure all the internet connections are active. That way, when you are hot failover, it's going to be instantaneous. It's going to be seconds.
Yeah, the other thing that I will point out too is like they're the two priority two that's bonding those two together, and that also inherits that hot failover. So if WAN 1 isn't there and then you're bonding two of those cellular connections, if one of those cellular connections drops, you still get that hot failover benefit. So any traffic that was using that cellular 1 is seamlessly handed over to cellular 2, and cellular 2 needs to carry that load now, but those sessions are maintained and handed off seamlessly between those, even in the bonding scenario.
And once your tunnel's created, the magic in all of this is outbound policies. That's really, so SpeedFusion is Peplink's #1 magic. Outbound policies is Peplink's #2 magic. The ability to control by source, destination, and even application like FaceTime and Zoom and Teams, etc. That outbound policy traffic shaping really matters. You have to use both together. And you think of SpeedFusion, whether it's SFC Protect or SpeedFusion to your data center or SpeedFusion Relay to your home, those are all just additional internet connections that you can then use to send traffic. And so that's why it's a little bit more, there's more to it. And we have an entire webinar on outbound policies. But in control, if I go to outbound policies, now that we've created our tunnel in control, I can create outbound policies right here. So you can see here's my bonding to SpeedFusion GNV, which doesn't exist anymore because we deleted it. I can create a SpeedFusion profile that bonds to the SDX, you see? And I can make my destination IP address, network, domain name, group network, SaaS, or even region. So I can have a SaaS like FaceTime and Teams. So it's going to bond based on those SaaS applications, FaceTime and Teams, to my data center. I can also do the exact same thing for SFC. So they're sending to my SFC platform. So you can use SFC, you can use outbound configuration, or you can use outbound policies to send that traffic or see how you want that traffic to go. But the magic with SpeedFusion is enhanced by the power of outbound policies and telling your traffic how to use those connections. We are running over, so I'm going to say if you have any additional questions, please feel free to email travis@peplink.com or peter@westnetworks.com. And we would love to, outbound policy is on peplinkuniversity.com or Peplink, youtube.com/Peplink, and under the Peplink University playlist, you can see those outbound policies. But if you have any questions outside of this, please send us an email. We'd love to answer those questions. And there's a lot here. And I just wanted to have a quick video that people could watch and reference to understand what SpeedFusion is and how it works. Thank you so much for your time, Travis. Thank you once again for 14 successful video platforms here, or videos here. And I look forward to the next one.
Absolutely. Thank you all folks for joining, and yeah, we'll be back in a month.
We'll see you next month. Have a good one.
Thanks folks. Goodbye.
Bye.